Some people say, like, well, how does it work from a chemical standpoint? It's pretty simple, hydrolysis, and then you have a beta oxidation, and you'll see at the end you have biomass and CO2, regular bioremediation. Same science in the wastewater treatment plant, nothing special, just smaller and controlled. So we're not doing anything magical with it, we're just doing the same thing that you do in a wastewater treatment plant on a smaller footprint and for much less cost. So some of the customers' installs, as I said, we really developed this for 6 years at the Montage Resort in Laguna Beach. It sort of was our sandbox, if you want, so trying to figure out what are the dynamics of a grease interceptor and how do we do it. We also did the Glen Helen wastewater treatment plant in San Bernardino, which is hooked up to a county jail. And so that was really sort of the toughest thing for testing and for having a client, because they throw a lot of stuff down the toilets in a jail, especially when they have riots. So you couldn't have anything worse than that. And you can see here on the left side how bad it was. It was like 3-4 feet thick. And then on the left, on the other side, you can see pretty much after a couple of weeks, we got some significant reduction. System has been in place for 2 years. They haven't had to pump it ever since. This is the Sierra Madre Foods. This is actually the site where you saw the video feed, the time-lapse movie. Same thing. We've been with them about 3 years. Never had to pump either. City is really happy with it. No violations. All that. We do also lift stations. There's a particular lift station in Santa Elia Water District, Cardiff by the Sea, where you can see lift stations lately have become a big grease problem because the recession, people start cooking at home. So the grease ends up in the lift stations versus in grease interceptors or grease traps. And that's a huge problem for the city, who anyway has ever shrinking budgets to now address more grease in lift stations than before. Here we did at the Montage a little comparison. We can actually beef up the system, or we can control the system remotely to say, I want all grease gone. As I explained before, that's not preferable because we do actually put somewhere in the neighborhood of 4 cubic feet of air per minute into the interceptor, and it needs to come out. So we keep a little blanket on top of it that sort of keeps the odor in. But for demonstration purposes, we just beefed it up. And so you can actually see here, this is actually an intercept. This is how we could treat it if we run it all the way up versus basically, if you want, sort of a baseline. So we actually replumbed a little bit at the Montage to sort of get a baseline, because we had to build an entire mathematical model of the intercept in order to design this. The benefits, it's very cost effective, it's very reliable. As a matter of fact, we can directly compete with pumping. Even save you some money on top of it. Just a little bit, 5–10%, but like pumping. We don't use enzymes. There's no recongealing. We have remote monitoring and alerting. There's actually a level sensor in there, so if something gets clogged, it immediately kicks out an alarm. So if you're a restaurant owner or a hotel owner, you don't have to have the nasty news that it overflows. You get at least a little bit of a heads up. It's beneficial for the sewer system. We have that data as well, because we don't bypass it, and there's some residual microbes that come down that also help the sewer system. And we don't just add microbes. You know, so we understood that there's a retention time, so you had to have the bioelements shielded. You have to increase the retention time. You have to disrupt the channeling. So there's a lot of fluid dynamics and physics challenges that had to be overcome in order to make this work. And at the end of the day, it's just very simple wastewater treatment science. As I said, the science itself is nothing special. What we did is we threw on a lot of electronics and a lot of controls, and a very interesting design that's very cost effective. So it's Wi-Fi capable, so we have some water districts that actually put that into their VASH network. Then we treat all chambers now. Some of them have redundant level sensing. Some customers, we do temperature and pH logging. We have data, of course, that it reduces hydrogen sulfide. We have a pH balanced discharge, and as I explained, we have this UV processing that actually measures how much grease is in there. So the camera feed that you see is also a sensor. So that's really real quick about this technology. If you have any questions about it, how we did it, please. Yeah.
Yeah, my name is Michael Kellerman. I'm a certified wastewater operator and environmental engineer at InSinkerator. Mm-hmm. And I'm curious, you mentioned pH balanced. Do you do data logging of pH on the effluent? You talked about anaerobic conditions and low DO, and typically acidic pHs are the norm in a grease interceptor. So what's that? And you briefly mentioned about odors as well. If you've got positive displacement of air going into this system at 4 cubic feet, that's got to be displaced someplace. So I would be concerned about odors, if you could comment on both those.
You'd be concerned about odors?
Yeah.
Yeah. What happened with the discharge is, what we found out, the dynamics in it is if you let it go anaerobic, you need a massive amount of air to bring it back aerobically. Where the pH, a lot of the pH that actually is formed in the grease interceptor is the hydrogen sulfide production. If you look at just the cleaners themselves, they're not really a big issue because of the dilution ratio. I mean, the cleaners already get diluted in the kitchen, and then they get diluted one more time in the grease interceptor. So we found out if you keep the thing aerobic, the pH is just about, well, say neutral. It's always above 6. Let's put it this way, maybe 6.5. We have 7 is usually what we strive for. As for the odor, yes, the interceptors have to be vented. They should be vented by code. We had a couple of sites where we had real issues with it, and then what we do is we actually put a vac system on it where we actually remove the odors, and we scrub them. But these odors in a fully running bioreactor are actually only the food odors, because again, when you have the system running completely, there is really hardly any grease in there, so that you don't have any of the foul odors. You can actually open up the manhole covers, you can work at it, and there's really no apparent smell except the food smell, because you continuously put in food. And it's really interesting psychologically. People say, smells good, till they know where the smell is coming from, and then all of a sudden it's not so good anymore. I know, Milt, you know a little bit about that too.